So as you can see, this is like a tapered spline. It's got like quite fine teeth on there, but it just chews up the plastic. And look at one of my previous videos, I tried putting like a cutout for the nut which screws on here. This is 8 by 1 millimeter pitch. Most 8 millimeter nuts and such like 8 by 1.25 so far as I know, so it's an odd size nut to start off with. Sometimes I think they do things so they're not helpful. So what I was thinking of doing, I've thought about putting a pin through here, but that would mean drilling a hole in this shaft and mucking about. I don't really want to do that. By the way, this, just in case you didn't see in my earlier sort of videos, I have a playlist about doing this. This is just a, well, it's a quite wideish washer. The hole was too small, so I reamed it out with a tapered reamer. I kept reaming a bit off and pushing it on to get just to fit onto the spline shaft. And I think it just grips the splines. That's on there pretty tight now. The previous iteration I did with the nut, that was extremely tight, the plastic part I had connected, but was still slipping. It was chewing up, the plastic was chewing around the head wasn't gripping in the plastic enough, but it was so tight I had to actually saw it off, the plastic part. I couldn't get it off any other way. Anyway, waffle. So what I was thinking of doing is getting a wing nut with wings on, and that would, like, the two wings would dig into the plastic in a way more and spread the load more, because I want to make sure that this is certainly gripping. That's what I want to do. So, and well, I haven't been able to find a wing nut that has 1 millimeter pitch. They're all the 1.25 for the 8 millimeter thread on here, like a bolt almost, part of the thing. So just found this. I'm not even sure what it's off. I think it's some sort of catch off a cupboard or something, or you know, the hinges. So that's obviously for 2 screws to go in there and like a bolt to go in there. Obviously that's too small, so I intend to drill that out 7.5 whatever and then tap it out. I do have some taps that'll do. Well, I have a set of taps for putting threads on things and dies, and tap that out to 8 by 1 millimeter pitch, and then that would bolt, well, this would actually screw on those threads and put the nut on top of that. But the idea there is to have this like actually going into the plastic, and that's because it's going to be banging up against this edge here. There's like a lip on there. It's not going to turn any further that way. It's going to reach the limit of its turn, and with the nut on, that will probably also help it stand with when I want to do this in reverse, which I want to do to release any jammed plastic, etc. if it, well, it works reasonably. It'll hopefully stop that doing. So I'm going to do that. That's the next thing I'm going to try. Okay, I have been working on this. That while I also work on this, so to speak. So I'm going to drill that out and tap it out and see how well it fits on there. Okay, by the way, that hole there is not central. It's my very old Vice Spear and Jackson, had it many years. Right, get on with drilling that out, tapping it out, etc. So drill that hole out to 7.5, which is I think the nearest one I've got. And I've got this dirt cheap tap and die set. These are cheap. I have replaced some of the taps here, see the silvery ones. So this is, well, it's got stamped on it 8 by 1 millimeter pitch. Let's see. So should have 8 by 1, and the common size is 8 by 1.25. So check that you're getting the right size. But this is 8 by 1, and I'm going to double check by seeing if the nut actually goes onto this tap. So these are dies for cutting the external threads. You can get split dies, which I would recommend rather than these. And these are taps, the ones for actually going into a hole. Okay. Had this quite a while. It's okay. I don't use a lot of taps as dies. So yep, that nut goes onto there alright, doesn't bind up or anything. It's not cutting at all there. Right, so that is the correct tap for that. Just double checking, because that is the nut that goes on the tapered spline thing on the windscreen wiper motor on the end of that. Right, I'll tap out that hole with that. So yeah, I'm just undoing the tap now. When I was drilling, it seemed to do a bit of a, let's call it a mushroom. It's coming out. I think that's a coating on here. I don't know what type of coating it is. It's some, I think it's some sort of possibly chrome coating on this bracket thing. And plenty of videos about tapping, and just you go in a bit and turn back a bit, go in a bit more, turn back a bit to release the cuttings as it's going through. Might have to file this top down, I don't know. See that roughness on the edge, that was the drill that. Just using this old towel to be oiling it. Okay, so those taps aren't too bad for cheap taps. As I say, I did replace some of the more common ones with some better quality ones after quite a few years. So yeah, it's got some quite sharpish bears on here on the underside. That's mainly the drill that's done that. You can probably see some of the threads inside there. So I'm going to get a file and file that down a bit. There we are, filed off the bears there. Right, I just thought there when I was doing that actually if it gets really doubtful whether it's slipping or not, you could put some screws in each side of those, well, each of those holes. As I say, that's not a central hole. I think it's about 1 millimeter over, so to speak, of being central, but it doesn't have to be perfectly balanced in this case. There's a tape to V-mat at the bottom, and like a normal bolt in a way at the top. Let's see if this screws on. Going on a little bit crooked there. Trying to do this left-handed and one-handed. There we go. What we call snug there. By the way, if you do get split dies, there's like a chamfered bolt type pointed bolt you can put in between the split, and that'll open them up or close them up more. pretty tight on there actually. How is there enough space to put any sort of nut on there? Not much space there, is there? That's, just a second. Grip it would cushion my fingers a bit. Right, that's on there, very tight. So in a way that's there's going to be cut out in the plastic. So this is an earlier one I did, one of the first ones I did. It'll be cut out in the plastic there for this to go into. Let's try that nut. Reiterate, 8mm by 1mm pitch. I don't think that's going to go on there. Let me have a look at that. I thought I'd try it on almost what term is upside down here to see if get. So there's not much thread sticking out there really to put a nut on. The only way I do that is by filing this top, this bump down here that's on this. I don't want to do that initially, that's for sure. So can you see the bump there? I reckon that's about 5mm deep, that. I'm not sure. I think that's, looking at that, that's about 8. So screwing this on all the way is only going to leave 3mm at the end. As I say, file this flat. Then that's going to lose thread and some of the threads inside there. I would like a nut on there to like lock it off so that won't turn backwards. Well, I think that'll stop it slipping as it's turning, because obviously it's going to screw on all the tighter. We'll have it, so the direction will be this way. So if you put the negative on here, positive on there, that's high speed. Low speed is up there, but low speed on this motor I have here, this actual one, isn't working. I think the carbon bush inside is bust. Well, I'm only using high, so I can only use high speed. All I have to do is swap those cables, well, wires over, put positive on there, negative on there, and it'll turn the other way. See, positive on there, it's going to turn clockwise when we're looking at it here, and anti-clockwise if you swap those wires over. Obviously if I swap the wires over, and I don't want reverse on this if I'm going to have it as a shredder, if any bits get stuck in the shredder you want to be able to slacken off the forces on it. That's going to unscrew it unless some Loctite. I don't know if Loctite's good enough. I've never used Loctite before. See how many, there's only about 1.5, 2 threads sticking out there. There's no way of really putting any, but I think I'll try that just to make sure that it's not slipping. Well, hopefully this will make sure it's not slipping, so to speak. So I'll get a plastic part made for this, printed out, etc, etc, get together, and then I'll come back. Okay, I'm going to try it out. Show you around a bit. Okay, so I've decided to put this almost upside down. That's because I think it's going to give even more grip into the plastic. This is just a test piece I've been printing out to make sure the measurements are okay. It'll come out now. Just a second while I get that out. So see, it's got these like almost like bumps on that side. It is meant to go this way up because it's got countersunk sort of for screws going there, countersunk marks. So that just pops in there. It does go a certain way around this one because it is, the holes aren't perfect. That middle, well, the central hole is not totally in the centre. I think it's 1 millimetre out. So you have to allow for that, basically. That basically fits in there. Still got the spline, the second centre spline tapered hole in the bottom here to go on the tapered spline, but it's not going to rely much on that to turn it. It's going to rely more on this plate that'll stick in, especially when it's like screwed in more. Right, I'll print it out there. Let's have a look at that. You can see that. Trying to get just, I haven't got my lighting set up. Just want to try and, you might see that that's tapered, that spline. It's almost curved as well, so it's almost like going round and in to the point, and then there's a like that lip there, and then it's got this 8 by 1 millimetre, that's 1 millimetre pitch thread on there. Okay, this is the wiper motor I'm trying out. Now I'm doing this to make sure it's not going to slip, because it could have been in my previous one that this was turning, but the washer might not have been, or what have you. This big washer here, which was just a pretty normal standard, quite biggish diameter washer that I reamed out until it would just, with a tapered ream, it just fitted on the edge of the splines there. Okay, here I am printing it out. I've got it set to 80% infill for this print here. I want it pretty strong. Get that light. You can see the infill better. So he's got the slot for the part to go in. You hear that background noise, it's just filament run out jam detector I'm testing out. This is has an idler wheel type thing. Probably you can see that inside. Instead on the other one I have like dual gears. And that's what's making the noise. Well, I think it's because like a skateboard bearing type thing with a groove in the outside. It's rubbing against the plastic here. But in the next iteration I've changed it slightly so that hopefully that will stop that noise. Listen to it. I call it a clever filament run out detector. Well, it detects jams as well. Has an encoder wheel here and optical end stop. If the wheel stops for either if it's jammed or if it's broken, it'll send us, well, stop sending this pulse over in a way, obviously, and that will go through the change filament routine It works okay. It's just this noise on it there. As I say, on the next printout I have of this top part here, that has the idler bearing in. There's a bit of a change, so I'm hoping that will stop that scraping against it. Actually, let me feel that. I can feel a bit of the vibration there. Right, okay. Thought I'd just show you it's mainly doing it at 80% infill here. Generally I use the LCD 128/64 display. This is dual display here. Can set it to the other one. This is for the lights, LEDs I have on here. There we are. So you can turn those on and off. Just LED strip basically. This one's to let me know that there's a cooling fan, well, a couple of fans actually inside. Altogether there's 4 fans inside, 2 are on all the time, but there's 2 extra fans, so it's gone out there under the thermostatic control of the power supply unit. Tell me when that's come on. See, so those 2 fans have stopped, but the other 2 fans I have on all the time. We just wanted to show you the time there, approximately halfway through. So 5 hours 16 minutes. Is the remaining time, 3 hours 22 minutes, that's all approximately. 200 on the nozzle, 60 on the heat bed. I have the fan set to the part fan PLA set to 100% there. I am sort of working as well on like a ring fan blower type device that will blow down more than this one, so rather than see it blows across from right to left. It is a blower. This part fan here. It comes down there and then it blows right across the nozzle basically. There's a video bit about this. So I have been working on a ring blower that will blow a ring of air around the nozzle, blowing down. It should be better. I mean, this doesn't. I've got no real problems with this. That's okay. PL touch there, Reality Ender 5 Plus. We're working on this. We're going out of focus. Oh well, anyway, it's mainly I think just talk about the 80% and we're about halfway through looking at this bar graph here. It all depends how much how much time is left in a way. Okay, yeah, you know, but you can't really go by it, because if it's got a lot of printing to do on the back end of the print, then it might still show 50% and then it will slow down. But if it's only got a little bit of print to do on the back end of the print, and the other way about. Okay. Well, there we are. Put it in here. I've got 2 M4 bolts in there. I drilled out the holes a bit. Does about 5mm long, just to make sure that it's not going to slip. Now obviously it is possible that it could still slip, but it's going to push against these edges on here. That's why I put it in a way this, well this is upside down to how it would normally go. I think it's like a for cabinet thing, like a bolt through there to a cabinet. Still got that washer on the back end there that I reamed out with a taper reamer just to get it to fit on sort of the tapered splines that are on this windscreen wiper motor. Just fits on there very tight actually. Right, let's get this connected to the thing. Now one problem with this, well, the way it is at the moment, it's okay going in the direction I want it to cut, but as soon as I go in the opposite direction, say you want to relieve, I do want to reverse on this if ever I get going. This is all proof of concept sort of thing, it's all prototyping. If I ever get going really well, I mean the last iteration went very well, but I just want to make sure that it's not going to slip at all as much as possible by doing this before I continue on doing anything on else or anything a bit different. As I say, if this goes, if I do the reverse in this, it's going to undo this bolt here on this sort of device I have in it. Well, the only thing I can think of there is some Loctite or something. I don't have a clue how good Loctite is, to be honest with you. There's different, as you know, lots of different Loctite, let's call them standards, you know. Some are more suitable for use where there's oil or water, and some are more easier to undo if you want to undo them. So I'm just showing you around that while I'm waffling on. There's a plug sort of thing. Can you see that? There's 5 prongs, so this is button 2 for high speed. Now normally you'd have negative, neutral, so yeah, negative, should call it negative because it's only 12 volts. Negative on the left and positive on the right. That's for high speed. But I'm going to swap them over to get to go the direction I want. There's negative there and positive over on that top right hand one if you want to go low speed. Low speed's not working on this motor. When I got it, wasn't working. I think the carbon bushes, 3 carbon bushes inside, and when you switch over, whichever contact you're using uses different coils, I think. The other contacts there are for what is known as parking switching. That's not car parking, it's where the wipers park. Obviously if you turn the wipers off and they're like that, they're going to be in your way as you're driving along. So they want to continue on a bit into what they call a parking position out the way of the windscreen, so that you can see ahead. And that's what is known as parking in this case, and that's what these other contacts are for there. There's like a switch mechanism inside. Now you have to watch with these. I'll just say that I did see online when I was doing some research into this, is that some have like a cam switch in, that if you put them in reverse, the cam is going to stick against the contacts, so to speak, and probably damage them. But I think most of them are more like this, where they're just in a way flat contacts, which it doesn't matter in this, like on this one, it doesn't matter which way around it goes, whether it's going forward or reverse, it's not going to impact it. So there we are, there's all that. I'll get this connected up to the shredder with the bolts, and we'll try again. If at first you don't succeed, try again. Okay, I've obviously bolted it down, etc, etc, wired it up. So this is using this, hopefully, well, it should be a non-slip sort of thing I had lying about. I think it's off an old cupboard. Two 4mm bolts in, as I showed you. Let's turn this on. This has a bit of deliberate looseness on this big nut head, well, bolt head here, to give it a bit of flexibility. No, well, I don't understand that. See, that disc is turning, so that's indicating this is turning. Well, how can it be? Not with that device on, surely. What's going on there? I mean, if I was tightening that nut up, well, that nut device up, by now, it surely should be tight. But you can see that's turning there. Sorry, the focus on this camera is playing up for some reason. See how that's turning there? This is jammed. Am I thinking, have I got this going the correct way? Yeah. That's turning this way, like clockwise, looking at it. That means that the nut's in a way turning that way. Well, it's not a nut, it's like a little metal plate. And that should be tightening it, not loosening it. I'm going to have to take this off to have a look inside, see what's happened, if anything. But that's worse than what was before. Right, I've loosened the bolts off here. This does feel very loose on here, so you're going to see it same as I see it. It looks fine. See inside there, I can't see any chewed plastic in there. I don't understand. Can you see anything? Any chewed bits of plastic up or anything? There's a big bolt that goes on to. 22mm bolt there, which has the cutting disc on. Right, I'm going to have a closer look at this. I'll do this off camera, but I can't see, I don't understand that. Well, straight away I went to turn this a bit just to see what's what, and it stripped the threads out of this plate here. So look, I can turn this, which is like the shaft turning inside that, and see how it doesn't, I can get that in the camera, and the shaft isn't turning, so it's not gripping, even though that's a threads cut on it. So it must be quite softish metal, that. So that is a total failure. Let's can we unscrew this yet, which is unscrewing. I think there's a bit of metal there. Yeah. Be careful, because sometimes you can get sharp bits of metal. There's a tapered spline beamer. Yeah, there's bits of sorry, I was interrupted by my grandson there after some sheets of paper. Wants to do something, I don't know what. So yeah, there's definitely chewed up there. That must be quite softish metal, that plate there. I didn't even think about that, to be honest with you. Right, fail, big fail. Right, I've took it off. I see there's bits of swarf, I'm going to call it. Yep, so that must be quite softish metal. Just a second, I don't want those getting stuck in my finger. That must be quite soft metal, that. Something, I didn't even think about it. It's plated, I think, so hard to tell. Yeah, chewed up the threads in there. Just show you inside here. You can see that those two 4mm bolts have actually pulled this plastic up a bit to shape the. These are meant for countersink heads. These plates are meant to go on sort of that way around. Put countersink screw into there, and there's some sort of bolt there for cabinet hinge on a cabinet, I think. Remember right? Just showing you, not really much damage there. Tiny bit of metal. So I'll screw this on here, and see, I can just keep turning there, because those threads in this plate and ripped out basically. Fail.